Here is a geometry pattern that I'm sure most of you would have seen before. If not, you can see clearly how it develops. Triangular dot pattern. And if we count the number of dots, 1, 3, 6, 10, and so on, then of course these are called triangular numbers. How would we get a formula to represent those numbers? What is it that's special about that number sequence that will help us? Well, one thing that's worth bearing in mind with any number sequence is always worth looking at the differences between the numbers. 2, 3, 4. And then looking at the differences again, 1, 1. And if we did 2 or 3 more of these, we would find that all of the second differences, these are called the first differences, these are called the second differences, all of those second differences are the same. And that tells us that it's what we call a quadratic sequence. So I'm going to try and find a formula for these red numbers. There are several ways of doing this. I'm just going to look at an algebraic way of doing it. The fact that it's quadratic means that the equation will be something times n squared plus something times n plus c. In other words, our quadratic formula, where n stands for which number. So n equals 1 is the first number, n equals 2 is the second number, and so on. So n is the position of the number. Well, I'm going to do a little bit of algebra. So when n is 1 in this formula, a times 1 squared is a, b times 1 is b, plus c. I know what the first number is, it's 1. So that has to equal 1. The second number, n equals 2, 2 squared is 4, gives me 4a plus 2b plus c. What is the second number? It's 3. And then the third number, which is 6, 3 squared is 9. Let's make a note of that, n equals 3. 3b plus c, and the third number is 6. So this perhaps looks a bit scary to some of us because I've got 3 simultaneous equations. Fortunately, they've got something about them that's quite easy to handle. Let's give them a number. What do you think it is that is the thing that's easiest about these equations? Did you get it? It's the fact that they've all got plus c, which enables me to get rid of that c very easily. And I'm actually going to work upside down. So get your upside down thinking hats on. I'm going to start at the bottom, and I'm going to write down line 3, take away line 2. If I do line 3, take away line 2, I get 9a take away 4a, which is 5a. 3b take away 2b is 1b. c take away c is nothing. 6 take away 3 is 3. And I'm going to call that line 4. Always worth, when you're solving lots of simultaneous equations, number each line. It stops you getting lost. Because I can look at this and think, oh, where am I? I've lost myself. No, I know where I am. We're going to go line 2 and line 1. So we're going to start at line 2 and take away line 1. So 4a take away 1a is 3a. 2b take away b is 1b. The c disappears. 3 take away 1 is 2. And they're already looking a lot easier, aren't they? And again, something nice and easy. It always works like this. You don't have to try too hard with these. They've both got a b in. So all I have to do, now I'm going to work downwards again, which you're more comfortable with. 4 take away 5. 5a take away 3a is 2a. That goes. b take away b. 3 take away 2 is 1. A is a half. I don't just want A, I want B and C. So where can I go? Which equation would you go to next? I'm going to go to 4. Because 4 says 5A, 5 lots of a half is 2.5, plus B equals 3. Great, that gives me B as a half. And then finally, where shall I go? Well, I've got A and B. I can go back to here. A and B are both a half. Half plus a half plus C has to equal 1. And so you should be able to see, of course, C is nothing. So C is 0. And I've done it. I've got my formula for this number sequence. So the formula is a half n squared plus a half n. If your algebra is good, you might be able to see that I have a common factor of a half. I also have a common factor of n. I can actually write that as a very, very well-known formula, which you could quote if you could remember it, the formula for triangular numbers.